Hello guys, how are you today? I hope you're fine and you might be doing very well and you're very excited for this new video. Welcome to the channel VIBGYOR of Talent. So I'm back with an amazing video. You might be awaiting for this for many days. So this video is going to be really awesome and helpful too. Okay, in today's video we are going to look at the chapter Quadrilaterals. It is the chapter 8 of class 9 NCRT, and we are doing the second part of this chapter. We have already completed the first part of this chapter, and we have learned pretty much stuff in the first part, which was very important and mark scoring, and we enjoyed a lot. So in today's video, we are going to look at the second part of this chapter, Quadrilaterals. So this was the first video of Quadrilaterals of VIBGYOR of Talents. So if you hadn't watched it, I recommend you to watch it now because this is the continuation of the previous part of this chapter. So you might not understand this part pretty well if you won't watch this video. So for the ones who hadn't watched the video, don't at all get worried. The link is in the description. If you hadn't watched it, you can just watch it right now and continue watching this. No worries at all. Okay, so in the previous video, we have looked at the introduction of this chapter, quadrilaterals, and pretty much stuff that we already learned in the previous classes, such as we can see quadrilateral in our surroundings like blackboard, book table, etc. We discussed it more other stuff that we already learned in the previous chapters or the previous classes and that we already generally know. So in today's video, we are going to look at the topic angle sum property of a quadrilateral. Many of you might be knowing already about this angle sum property of a quadrilateral, but 90% of you might be definitely knowing about the angle sum property of a triangle. So what is the angle sum property of a triangle? Sum of the angles is nothing but 180 degrees. So using that only, we are going to prove the angle sum property of a quadrilateral. We are going to know about it. So actually this is a marks scoring chapter to say. We'll be getting many marks for just writing a simple proof, which is going to be very easy. So let's see what is the angle sum property of a quadrilateral. So the angle sum property of a quadrilateral is the sum of the angles of a quadrilateral is 60 degrees. So let us now recall the angle sum property of a quadrilateral if you have already known it. So this can be verified by drawing a diagonal and dividing the quadrilateral into two triangles. You can take any quadrilateral, you can take the quadrilateral that you can see in this picture, or otherwise you can take your own quadrilateral. So just take any random quadrilateral and just divide it. What is diagonal? You might be knowing about it. Diagonal is something which divides the entire picture into two halves, two equal halves. So they should be congruent to say, particularly if you actually know the meaning of congruency. Okay, so just draw a diagonal and make the quadrilateral into two equal triangles. You can do it like this, as you can see in this quadrilateral. Just take the quadrilateral A, B, C, D and let A, B, C, D be a quadrilateral and the AC be diagonal. Take AC as a diagonal. You can take anything, but just for an example, I'm showing you AC is the diagonal. So, and then we have seen that we took ABCD as a quadrilateral, draw AC as a diagonal. So what is the sum of angles in any triangle? As I said you right before, the sum of all the angles in a triangle is nothing but just and just only and only 180 degrees. So what do you think is the sum of angles in the triangle ABC? The triangle that you see on the above part of the quadrilateral, or for sometimes we can call it also as left side, I guess. Okay, so what is the sum of angles of this triangle ADC? Now you should be definitely telling that it is 180 degrees. So we can write it also in the form that angle DAC plus angle ACD plus angle D is equal to 180 degrees. So we just named these angles before we said that all the angles in a triangle constitute to be 180 degrees. But we have taken each angle particularly. The bottommost one, angle DAC, the uppermost one, angle ACD, and the other one left over on the topmost side of the left side was angle D. So if we add all the angles in this particular triangle, we are going to get 180 degrees. That we know by the angle sum property of the triangles. So similarly, look at angle ABC, triangle ABC in the same quadrilateral ABCD. So what do you see there? Again comes the angle sum property of triangles, and here also we can write it as angle CAB, the bottommost one, and then angle ACB, the uppermost one, and the lower bottom one onto the right side corner. So that is angle B, and it constitutes to be 180 degrees. So anywhere you see a triangle, if someone asks you anywhere what is the angle sum property of triangles, in any triangle, any triangle, you can take scalar, isosceles, equilateral, any triangle, the sum of the angles would definitely be 180 degrees. So we can prove it also in many ways. You might be already learned it in the previous classes or the previous chapters of class 9 only about triangles more deeply, but now we are going to look at quadrilaterals. But basically quadrilaterals is made up of many triangles, basically two triangles that we took here. So it's just dependent mostly on triangles, so you should be perfect with triangles so that you'll understand this chapter of quadrilaterals much more easily and simply. Now let's make these as equations 1 and 2, that angle DAC plus angle ACD plus angle D is 180 degrees, that is equation number 1, and angle CAB plus angle ACB plus angle B is equal to 180 degrees. Let's make it as 2. So what do you think we will get when we add equation 1 plus equation 2? It would be somewhat like this. So just we are going to add everything, then it would become angle DAC plus angle ACD plus angle D. This is the first equation, right? And then we have angle CAB plus angle ACB and plus angle B. So what is the sum of these three angles in the first equation? It's 180 degrees, we wrote it over here. And what is the sum of the angles? The second one, the second equation, it's just 180 degrees, again we wrote it here. So what is 180 plus 180? You should be able to do this calculation if you have studied your first class pretty good. Hey, just kidding. Okay, so 180 degrees plus 180 degrees is 360 degrees. So now the sum of all the angles in the quadrilateral came out to be 360 degrees. So also we can make it more simpler. So also angle DAC plus angle CAB is angle A. It's as simple as it. You should be knowing that angle DAC plus angle CAB is of course angle A. That is the entire angle that you find over here, the bottommost angle. And then angle ACD plus angle ACB is equal to angle C. We just combined two angles, that became one angle. Actually they are one angle, but when we drew a diagonal over that quadrilateral to just divide it and just prove the angle sum property of this quadrilaterals, we did it in such a way. So if we just make it as single angle like angle A and angle C, the work becomes more easier. Of course angle D and angle B are separated. So they are just separate from, they are not combined, they are separate. So we didn't touch them any all. And angle A plus angle D plus angle B plus angle C is 360 degrees. So that is the sum of the angles of a quadrilateral is 360 degrees. So what were we asked to prove? We were asked to prove the angle sum property of a quadrilateral. We just did it very easily. So as I have said, this is basically made up on the triangles. We did this angle sum property of a quadrilaterals also using the angle sum property of triangles. So you should be knowing all the properties of triangles pretty well to understand these concepts in just your fingertips. It would be just a cakewalk. Okay, now I guess that you are pretty perfect. The angle sum property of a quadrilateral. Now let's see the different types of quadrilaterals that we have. So what are quadrilaterals even? Quadrilaterals are nothing but just basic shapes that we see around us in the environment. So it's a pretty vague definition, right? We should be knowing what are the types of quadrilaterals to exactly know about quadrilaterals. It would be just uninformative if you don't learn about the types of quadrilaterals. So now we look at different quadrilaterals which will be very useful for us and which you see in your environment in your everyday life. So here are some types of quadrilaterals. I want you guys to just look at them very carefully. Each one of them, we have totally 6 diagrams over here, so I want you to look at each one very keenly. These are types of quadrilaterals. Just observe them. The first one, the angle, the quadrilateral ABCD. Second one, angle, quadrilateral PQRS. And the third one, the rectangle. Of course, it's a quadrilateral. We have discussed in the first video about this rectangles and quadrilaterals, the relation between them. So then we have the rectangle NMSR, and the fourth figure is the quadrilateral DEFG, and the quadrilateral ABCD is the fifth, and the sixth one is quadrilateral ABCD. So you might be not thinking that the sixth one is a quadrilateral, but definitely it's a quadrilateral. Let's know more about it in just a few minutes. So now, as you have observed them very keenly, I want you to just think of them. Just get good knowledge of all these quadrilaterals. The quadrilateral ABCD, PQRS, MNRS, DEFG, and ABCD, and the last one is also ABCD. So I guess you might have a pretty good knowledge about these. Now you had also thought about them for a while. So what do we observe from these? We are going to learn a lot of stuff from this part, about from these pretty diagrams, these 6 diagrams. We're going to learn many things using them. So one pair of opposite sides of a quadrilateral, the first quadrilateral, as you can see here, ABCD, in namely A, B and C, AB and CD are parallel. You can see them. You can directly, by visualizing only, you can imagine that the AB, CD are parallel. And you know that it is called a trapezium. So this is about the first quadrilateral. So remember that all that we are knowing now are types of quadrilaterals that are very important. The first one is trapezium. And then both pairs of opposite sides of a quadrilateral given in figure 2 here, figure 3, figure 4 and figure 5 are parallel. So recall that such quadrilaterals are called parallelograms. So quadrilateral PQRS of figure 2, the first one is a parallelogram. The others are also parallelograms. We can be pretty sure about that, but we are going to call them with pretty good names. They got good names. Okay, they are all just twins, but we are going to name them differently to just differentiate them very easily. So the second figure, PQRS quadrilateral, is a parallelogram. So parallelogram is also a type of quadrilateral. And then in parallelogram MNRS of figure 3, note that one of its angles, namely M, is a right angle. So it is called a rectangle. So wherever you see a right angle in a quadrilateral, you can just blindly write it as a rectangle. That's it. It's as simple as that. And then the parallelogram DEFG, that is the figure 4, has all sides equal, and we know that it is called a rhombus. You might be knowing everything beforehand only, you might be learning about these previous classes as well as in the previous chapters. And then the parallelogram ABCD of figure 8.5 has angle A is equal to 90 degrees and all sides equal. This is known as a square. And then in quadrilateral ABCD of figure 6, AD is equal to CD and AB is equal to CB. That is, two pairs of adjacent sides are equal. So it is not a parallelogram, it is called a kite. So I hope that you understood all about the types of quadrilaterals pretty clearly now. All these 6 figures that you saw and just thought for them pretty while. So you should be definitely sure and just get full marks about these in your examinations if you have understood my explanation. Okay, so here as you can see, we should note that a square, a rectangle, and also a rhombus are all parallelograms. This is a quite good fact that you might be not knowing before. And then let's look at some of the interesting facts, some of them like this, very important also. Okay, and then a square is a rectangle and also a rhombus. Okay, so this is the other one important point. And then a parallelogram is a trapezium. So you should remember these all very well. And then a trapezium is not a parallelogram. You can ask why? The answer would be that as only one pair of opposite sides is parallel in a trapezium and we require both pairs to be parallel in a parallelogram. So we cannot call this guy a parallelogram. And then a trapezium is not a parallelogram. So for this also we can get the same definition as only one pair of opposite sides is parallel in a trapezium and we require both pairs to be parallel in a parallelogram. So we cannot call this a parallelogram. And also a rectangle or a rhombus is not a square. So I am pretty sure that you should be understanding all these concepts. It was a little fast, but don't get worried. You can watch it how many ever times you like it. It's your own thing. I guess it's too fast, but these are very important topics, but you should learn them very thoroughly. So look at these figures once. Look at these figures very keenly. What do you observe in these figures? The figure 1, the figure 2. Okay, a time up. So here the area of the parallelogram is dp into AB and this is less than the area of the rectangle. That is AB into AD as dp is less than AD. So you should be understanding this. And then generally, sweet shopkeepers cut burfis in the shape of parallelogram to accommodate more pieces in the same tray. So see the shape of the burfi before you eat it next time. Oh, even I like burfis. So if you also like burfis, just let me know in the comment section below. So that's it guys for today. Thanks a lot for watching this video. Be waiting for the next video. It would be just amazing, and don't forget to follow all the videos, and if you like this video, give it a big thumbs up. Have a very great day. Thank you once again.